All right, so because a few of you guys were missing from the last class, I want to give a quick summary in order to help you guys do the homework a little bit easier. So the key concept we went over were the three kinematic equations. So the three kinematics, I would highly suggest you guys try to memorize these so that you're able to kind of think more abstractly about problems and solve problems easier. Rather than having to look these up every time. I know they're given to you on the test, but it honestly is really helpful to just kind of know what variables are related to each other and in what way. So the first three equations are v final is equal to the initial velocity plus at. Second equation is the displacement is equal to the initial velocity times time plus 1/2 the acceleration times time squared. And then the third equation is vf squared is equal to v initial squared plus 2ad. So a couple of things, you might see me write these in slightly different ways. So v0 or vi both stand for the initial velocity. And then some of you guys might have learned it with the other notation, so just make sure you're comfortable with both. D is going to be displacement, VF is final. So I think most people are okay with that. There is one other version of this equation for like equation 2 and 3, where the displacement is written as x is equal to x initial, and then the rest of it's kind of the same. But essentially it splits up the displacement as an initial position and the final position. In this class, we're going to be using D whenever we can. You might also see as delta x, delta y occasionally, but that just specifies the displacement in the x or y direction instead of d. So all three of these you might see as ways to write displacement. So keep that in mind. For our purpose, I'm going to stick to these three forms. If you have learned it in a different way in previous classes, right, just make sure that you can kind of translate it over and be able to do both ways. So that's the initial. So once again, VF is your final velocity. I'm just going to do a quick list of all the key terms, or variables rather. Displacement is D, which remember means your changing position. So how far your object moves, and A is acceleration, and T is obviously time. So one of the important things for these is you should know that all these variables, D, A, V, these are all vectors, so therefore they could be plus or minus. So you should always consider, am I going the positive direction? Am I going the negative direction? Set a direction before you start doing the problem, and then just verify that you have the correct plus or minus sign whenever you're doing these. All right, so key idea for this problem, in order to help us do the problems, is, like I said during the class, you guys should focus on what each one is missing, like which variable is missing from each equation. So our first equation is missing the displacement. Right, so no displacement. The second one is missing the final velocity. And then the third one is missing the time. Right, so based on which variable is missing, that oftentimes gives you a hint towards which of the equations to use. So in the general process of solving these, what you should be doing is, one, if you have no idea what to do, draw a diagram, because oftentimes this will help you come up with an idea or a better understanding of what's going on in the problem. So draw a diagram, whatever picture you need to help you understand. And then two, I would actually list out this list of variables. There's usually 5 variables as we listed here. So once again, that's these ones. So I would go VI, VF, and then DAT. Right, so you should know what all 5 of those mean. And so what you do is you just kind of gather the information from the problem, what each of these variables should be. And oftentimes in the process of doing that, one of the variables will you be searching for or looking to solve for, and then one of the variable you'll be trying to not use. Right, I try to write it is equal to x there. The x just means don't use that. That doesn't mean like that's a variable. So if I know all 3 of these other information and I'm still looking for displacement and I don't want to use time, which equation should I use? Well, since I don't want to use time, you go back and look at whichever equation doesn't use time and plug in the appropriate information. So that would be the third equation right here, right? Because it does not use time. All right, so I'll give you an example after this, but just this is as a kind of a hint. So hopefully this is good enough to help you guys do most of the problem. The problems are a little bit tricky, so spend a little bit of time thinking about it.